Hi and welcome to a video on types of enthalpy. In this video, I'll be discussing 6 different types of enthalpy and we'll be looking into the definition as well as example on writing thermochemical equation. Let's get started. Firstly, it's the standard enthalpy of formation, which has a symbol delta H, naught, and subscript F. By definition, enthalpy of formation is heat change, which means heat is either absorbed or released during this reaction when 1 mole of compound is formed from its element in their most stable state under standard condition of 25 degrees Celsius and 1 atmosphere. Now let's look into an example to further understand this. Here you are given the standard enthalpy formation of methane is negative 75 kilojoule per mole. So firstly, in order to write the thermochemical equation for formation, you must identify the elements present in methane. That would be carbon and hydrogen. Now ask yourself, what is the most stable state of carbon? It would be carbon solid, whereas for hydrogen it would be H2 gas. Now these two elements in their stable state would form our methane. Next, according to definition, you must realize that it is for the 1 mole of compound form. Therefore, make sure to maintain 1 mole in front of methane before balancing the equation. So that would give us 2 in front of hydrogen. Now that we have a balanced chemical equation, we can convert this into a thermochemical equation by writing the enthalpy value beside it. Since I don't have space here, I'm going to write it below. So it would be delta H formation equals to negative 75 kilojoule per mole. The next example here is on delta H formation of calcium carbonate with value negative 1206.9 kilojoule per mole. So in order to write the thermochemical equation, identify the elements present. That would be calcium, carbon as well as oxygen. The most stable state of calcium would be calcium solid plus carbon solid plus O2. For oxygen, that is the most stable form and it would be a gas, and this forms calcium carbonate solid. Again, stick to the definition and it says that 1 mole of compound must be formed. Therefore, the stoichiometric coefficient in front of calcium carbonate must be 1 and balance the equation by adding 3/2 in front of oxygen. Once we have the balanced chemical equation, convert it into a thermochemical equation by writing the delta H value, which is negative 1206.9 kilojoule per mole. Remember, you have to write all this in a straight line. I'm writing it below because I don't have space to write here. Now, the next important thing that you should know under standard enthalpy of formation is that standard enthalpy of formation of any element in its most stable state is 0. Now, how can we understand this further? So let's take an example of oxygen. Here you are required to write the expression for the standard enthalpy of formation for oxygen. Now ask yourself, how many elements are there present in this oxygen molecule? It would be just oxygen. And what is the most stable state of oxygen? It would be oxygen gas. Therefore, the chemical equation would look like oxygen gas changing into oxygen gas. When the chemical equation looks like itself converted to itself, that means the standard enthalpy of formation is equivalent to 0 kilojoule per mole. What's the take-home message for enthalpy of formation? It would be, when you're constructing the thermochemical equation, make sure it is 1 mole of compound form. Next, the enthalpy of formation of an element in its most stable state would be equivalent to 0. Now let's go on to the next enthalpy. It would be combustion. The symbol for standard enthalpy of combustion would be delta H naught and subscript C. And here heat is released, obviously, because there is no combustion that feels cold, when 1 mole of substance is completely burned in excess oxygen under standard condition of 25 degrees Celsius and 1 atmosphere. Do take note, 25 degrees Celsius can be also written as 298 Kelvin. Now let's construct a thermochemical equation for combustion. So here you are given the standard enthalpy combustion of C4H10 to be negative 2874 kilojoule per mole. So the chemical equation would begin with C4H10 gas plus oxygen, since it's completely burned in oxygen, and it is a carbon compound. Therefore, the complete combustion of carbon compounds would give us carbon dioxide and water. Based on definition, 1 mole of substance is completely burned. Therefore, we have to maintain 1 mole in front of C4H10 and balance the chemical equation by placing 13/2 in front of oxygen, 4 in front of carbon dioxide and 5 in front of water. Now that we have a balanced chemical equation, turn it into a thermochemical equation by writing the enthalpy value along with it, which is delta H combustion equals to negative 2874 kilojoule per mole. How can we interpret this? For every 1 mole of C4H10, 2874 kilojoule of heat is being released. Next, let's look at a non-carbon compound example. I have taken iron. So the combustion of iron would be iron added with oxygen to produce iron 3 oxide. Now based on the definition again, we have to maintain 1 mole of iron. Therefore, I'll be multiplying half in front of Fe2O3 and 3/4 in front of oxygen. Now, don't forget your physical states and conclude your thermochemical equation by writing the enthalpy value along with it. The third type of enthalpy that I will be discussing is the enthalpy of atomization. So what is this atomization? You can picturize it as making into atoms, and these atoms have to be in gaseous phase. The symbol for enthalpy of atomization would be delta H naught subscript A. The definition for enthalpy of atomization would be heat absorbed when 1 mole of gaseous atoms are formed from its element in their stable state under standard condition of 25 degrees Celsius and 1 atmosphere. Since heat energy is absorbed, delta H value would be a positive value. And the process of atomization involves bonds breaking. Now let's construct the thermochemical equation for the enthalpy of atomization of magnesium. By definition, we will be forming 1 mole of magnesium in gaseous state. And where does it come from? It comes from magnesium in its most stable state, that would be magnesium solid. The equation is balanced, so all we have to do is to complete it by writing the enthalpy value, which is positive 147.7 kilojoule per mole. Next, we have a non-metal example. So writing the thermochemical equation for atomization of phosphorus would look like phosphorus gas, and this comes from phosphorus molecule, which is P4 in the form of solid. Now based on definition, take note that it must be 1 mole of gaseous atoms formed. Therefore maintain number 1 in front of phosphorus gas. So in order to balance this equation, I have to put 1/4 in front of P4. And this process has an enthalpy of positive 242 kilojoule per mole. I hope everything is going okay so far. Let's move on to the fourth type of enthalpy, which would be the enthalpy of neutralization. Now, the standard enthalpy of neutralization has a symbol of delta H naught N, and the definition is heat released when 1 mole of water is formed from neutralization of acid and base under standard conditions of 25 degrees Celsius and 1 atmosphere. As for the example, we have a statement whereby neutralization of sodium hydroxide and HCl releases negative 57.5 kilojoule per mole. So let's convert this into a thermochemical equation. It would be HCl aqueous plus sodium hydroxide aqueous to form H2O liquid and NaCl aqueous. The equation is balanced, therefore conclude by writing the enthalpy value, which would be delta H naught equals to negative 57.5 kilojoule per mole. Now a little extra information here. During the neutralization of a strong acid and a strong base, you would get the standard enthalpy value to be around negative 56 to negative 58 kilojoule per mole. Anything lesser than this would indicate that the reaction is between either a weak acid or a strong base, or a strong acid and a weak base. Next, let's look into the enthalpy of hydration and finally solution. What can we understand with the term hydration? Hydration means we are adding water to it, or we can even say adding moisture to it. And the symbol for enthalpy of hydration would be delta H naught, HYD, height. And in this process, heat is released when 1 mole of gaseous ions is hydrated in water under the standard conditions mentioned. Here, the phase change that we are expecting is from gaseous phase to an aqueous phase. Now let's construct an equation for the hydration of lithium. So although it is mentioned as lithium, you must understand that hydration involves the changing of 1 mole of gaseous ion into 1 mole of aqueous ions. Therefore, I would begin with Li plus gas changing into Li plus aqueous, and this process releases heat with a value of 510 kilojoule per mole. Finally, let's look into enthalpy of solution. Enthalpy of solution is also known as enthalpy of dissolution, and the symbol for this would be delta H naught SOLN. The definition of enthalpy of solution would be heat change, which means heat can be either absorbed or released when 1 mole of substance is dissolved in water to form a very dilute solution under the standard conditions mentioned. So the substance that we are discussing here is an ionic compound. And what is the phase change that we are expecting? It would be from solid to aqueous. Now let's write a thermochemical equation for the dissolution of sodium chloride. It would be sodium chloride solid. Once dissolved in water, it would form ions, which is Na plus aqueous and Cl minus aqueous. And this has an enthalpy value of positive 6 kilojoule per mole. I would like to put in a kind reminder again that when you are writing thermochemical equation, the balanced chemical equation together with this enthalpy value should be in the same line. I am forced to write it below here since I don't have space. Okay. Next, let's try out some questions to reinforce the knowledge that we have learned. So exercise 1, you are required to identify the enthalpy changes. Question A shows half mole of nitrogen gas being converted into 1 mole of nitrogen atom in gaseous state. So that is a good indication that this is an enthalpy of atomization. Now don't just stop your answers there, you have to be specific by stating which species is undergoing atomization, and that would be nitrogen. So your answer should be enthalpy of atomization of nitrogen. For equation B, it is pretty clear that combustion is happening since the carbon compound is reacted with oxygen to produce carbon dioxide and water. So it would be the enthalpy of combustion of C3H8. Next, 3 mole of carbon solid is reacting with 4 mole of hydrogen gas to form 1 mole of C3H8. So this is definitely the enthalpy of formation of C3H8. Lastly, the equation shows an ionic compound in solid state being converted into its respective ions in aqueous state. So this must be the enthalpy of solution, or you can even say dissolution of lithium chloride. Next, let's practice writing some thermochemical equation. So here, let's look at question A. You are required to write the thermochemical equation for the enthalpy of formation of Al5H9. So take note of the elements present. It would be aluminium and also hydrogen. So the most stable state of aluminium would be aluminium solid, and the most stable state for hydrogen would be hydrogen H2 gas, and this would produce us Al5H9 solid. Since this is enthalpy of formation, make sure the number of mole in front of Al5H9 is maintained as 1. Therefore, I'm going to multiply 5 in front of aluminium to balance the equation, and also a 9/2 in front of H2. Once you have written the balanced chemical equation, convert it into a thermochemical equation by writing the enthalpy value beside it. So it would be delta H0F equals to negative 95.4 kilojoule per mole. So there you have it, a nice thermochemical equation with a balanced chemical equation and enthalpy value all in a single line. For question B, the thermochemical equation would be NaCl solid to produce Na plus aqueous plus Cl minus aqueous, and this is already balanced with delta H naught, and this is solution, so we would have SOL N as subscript equals to positive 6 kilojoule per mole. And finally, for the atomization of lithium, it would be Li solid to produce Li gas And this has an enthalpy value of positive 155 kilojoule per mole. And that's it, the 6 different types of enthalpy that is listed in your syllabus. Thank you.